All right, here's today's goal for math. You're going to learn to solve whole number subtraction equations. Only one word changed from last lesson's goal. Today's date and page number along with this. Here's your warm-up, some little practice from what you learned yesterday. What does x equal for each one of these? So you're going to have to use the inverse operation to solve them. Come back when you got the right answers. So here are the answers you should have had: 15, 87, 7, and 19. And remember, we can check our work on any single one of these just simply by plugging and chugging. Plugging 15 in here, plugging 87 in here, 7 here, and 19 here, and just working out that side of the equation to see if it equals the other side. And they all do. So today we're going to look at problems that have subtractions as the main operation and how we can solve for the other side of the equation. So when Theodore Roosevelt became president in the United States, he was only 42 years old. If you don't know, that's the black and white picture, president. He was 27 years younger than Ronald Reagan when he became president. So that means Ronald Reagan's older by 27 years. So here we can try to use A as Ronald Reagan's age and see what we're looking at. Well, we know that Theodore Roosevelt was 42. If we took Reagan's age and subtracted 27, we could get to that 42. But what exactly is Ronald Reagan's age? You should remember from what we learned yesterday, we're going to have to use an inverse operation to solve this and then be able to get our answer. So recall that with addition, we had to do subtraction. Well, with subtraction, we're going to do addition. So to get A alone, we add 27 to both sides. And the reason we add is because it's the opposite of subtracting. And doing it to both sides is because it can't just disappear. We just have to get it to the other side. So when we add 42 and 27, we find out that Ronald Reagan was 69 years old when he became president. Okay, let's start writing down some practice problems showing our work here. Let's look at this first one. So here we're trying to solve whether y minus 23 equals 39. It will, but what is the value of y? So again, we're going to use inverse operation, and what we're going to see is that the problem is subtracting, so the opposite of subtracting is adding. So to get rid of minus 23, we add 23, and what you do to one side, you got to do to the other. Now when you look, y is all alone, and 39 plus 23 is 62. And how do we check our work? Take that 62 and plug it right back into y, and when you chug out an answer of 62 minus 23, you get 39, so you know it's correct. Have this problem down so you have an example before moving on. Here's another one we can look at. So we have 78 equaling s minus 15. All right, so the opposite of subtracting is adding. So what are we going to add to both sides? The answer should be 15. Okay, so 15 is subtracted from s, and we're going to add 15 to both sides. So when we add 78 and 15 together, we get 93. Is that correct? How can we find out? Well, if we check it, we plug 93 in for s, and we subtract 15 away from that, we do get 78. So 93 is the correct answer for this one. You don't have to write this one down unless you want to. I would, because we just spent so much time going over it together. All right, let's look at one more together. Here it says z minus 3 equals 12. So we got to get z alone. So that means we got to get rid of the minus 3. So 3 is subtracted from z. That's the first thing we see. So that tells us that we're going to have to add 3 to both sides. Now this gets canceled and we're just left with z. And 12 plus 3 is 15. And you guessed it, we can check our work by simply just plugging and chugging 15 back in for z. 15 minus 3 is 12. Cool. Okay, there are 6 problems up here. I want you to go ahead and work through all of them, and when you're done, come back and we'll see how you did. Here are the answers you should have gotten. Every single one of them, all I did was I added whatever was next to the variable to both sides. That way the variable is all alone, p, x, a, y, n, and d. And then I just figured out the addition problem. Again, I can check all my work just simply by plugging the number back into the original equation and chugging out a value that's a solution. Okay, for this one, tell me whether the solution of b minus 14 equals 9 is going to be less than 9 or greater than 9. So you got to be able to figure out, looking at subtracting, will b have to be a bigger or smaller number than 9? And then explain how you know the number to add to both sides of an equation containing a subtraction. How do you know which number it is that's got to go to both sides? All right, go ahead and solve 1 through 6. And when you're done, we'll look at your notes. And that's it for today. See you next time.